presentation about respiration. So, what is respiration and why do we need it? Well, to start off, respiration is simply taking in our resources from outside our bodies to create energy, and in turn, to breathe out the waste that is created by creating the energy. In this case, the carbon dioxide. So, there are two types of respiration in general. There's anaerobic and aerobic. We're going to focus on aerobic since that is the main focus of breathing in and breathing out. Because anaerobic is without oxygen and aerobic is with oxygen when it comes to cellular respiration.
Every single organism has to respire either via anaerobic or aerobic respiration, sometimes both, from plankton to humans. Now the formula for respiration is glucose plus 6 oxygen is equal to 6 carbon dioxide plus water, 6, and plus ATP. While the water and ATP are immediately used, the carbon dioxide is exhaled.
But Akim, we forgot one thing. How does the gas travel into our lungs? Well, let me explain to you. The gases first start in either our nose or mouth. The gas will either pass through the nasopharynx or the oropharynx, depending on whether or not you breathed in through the mouth or the nose. After both pharynx, it goes into the glottis. And from the glottis, it goes into the trachea, or more commonly known as the windpipe. After the windpipe, it goes into the left or right lung.
So, the bronchus are tiny air sacs that are further divided into bronchioles, which are also subdivided into alveoli. When the air passes through the alveoli, plural of alveolus, the oxygen in the air gets transferred into the preliminary veins in the left side of the heart to be pumped throughout the body. The carbon dioxide is exchanged with the oxygen until the CO2 clears from the blood and is ready to be exhaled in the next cycle of exhalation.
So, Akim, how does the oxygen get into the alveoli?
Well, the alveoli you see are very thin. In fact, they're only 1 micron thick. That is 1/10,000th of a centimeter in length. So yeah, carbon dioxide and oxygen can easily flow in and out.
That's pretty small.
Wait a minute, something is missing. Why do the oxygen and carbon dioxide molecules change places? What forces is pushing them to do that?
Let us begin with the dart. If I wanted to dart this board, or this piece of cardboard, let's find out. Do you think it'll go through? Is it permeable?
In this example, I want you to think of the arrow as a molecule or atom. The molecule is trying to pass through a membrane, and the membrane in this case is the wood. Now the wood is impermeable by the arrow. However, if we take another example of something else, the cardboard, as you can see, the arrow passes directly through the cardboard, meaning that the cardboard is permeable by the arrow. However, if I try to shoot a dart through it, the dart is stopped by the cardboard. This means that the cardboard is semi-permeable, seeing as some things can pass through while others cannot.
This extended metaphor aims to explain us how diffusion works in our bodies. Just like darts and arrows, when oxygen-poor blood meets oxygen-rich air, they get exchanged and carbon dioxide get exhaled and oxygen gets inhaled.
As you can see, Eric's heart has stopped beating. Well, what does that mean to his body? Well, as you can see, his respiratory system is trying to exchange the oxygen with his blood. But because his blood is in a static place, it can't go anywhere. That means the oxygen and the carbon dioxide are in a state of concentration gradient where they cannot exchange with each other. Now, his body will desperately try to use anaerobic respiration to keep his body alive. Anaerobic does not require oxygen, as he's not inhaling any right now, but he will most likely be dead by the end of the sentence. Thank you.